for opening this first topic. And some of you have heard about Set for 2020, but some of you may not know in more detail what it's all about. So, Anton, can you just give a little background what it was all about to start that?
Yeah, well, before we got to SET, this all came about through actually a milestone decision at the community level, and that is setting up the European climate package. Just to go back a step here, what's driving all of this is the package which confirms binding targets of 20% renewable energy share by 2020. That's 35% electricity, by the way. It's going to play a key role in this country. 20% reduction of greenhouse gases, 20% additional energy improvement. Those are targets. It's a very important target-setting process here to drive the process. But maybe, just maybe, it's not quite as straightforward as targets.
Well, and the Commission, they did a calculation when they were setting up with all the people in Europe, and the status in 2005 was about 1,200 terawatt hours coming from renewables. That is mainly hydro, wind. And the 20% goal in energy, that is about 3,200 terawatt hours. And then they looked a little bit more in detail if we just go along as business as usual. And then they came up, well, 2,000 terawatt hours seems quite likely, but there is a gap. 1,200 terawatt hours. Where should that come from? And that is just now the gap in the terawatt hours. But Anton, there was in addition something else.
There's a couple of other gaps. CO2, for example. That's a little curve that just says how is CO2 in Europe, the EU 27 states, going to develop. If you look at the... Thank you, Manfred. If you look at these points here, that's the path we're on with the existing measures. You do some additional stuff, you will get there. This is what we have to get to on the target. We don't know how at the moment. And this is the additional voluntary target that Europe has said it will go for if the rest of the world plays ball. But there's just a small cap, not only with energy, but how to get this done.
Well, and then, together with A.T. Koenig, with the consulting company we did that study with, so they looked in all their big places where they have lots of information, what are the major sources to produce CO2. And as you can see here, so this is where over the last 40 years, most of the CO2 emissions comes from making electricity. So it is obviously quite natural to have a closer look to produce electricity without CO2 and at the same time adding more terawatt hours. So,
and also, when you think of energy policy to replace electricity in different other sources, what's available? I'm not going to go through this very complicated things, but as we're all at a photovoltaic conference, how did the world look at the importance of photovoltaic? Is this part of the solution, or just a nice little niche technology? This chart comes from the European Commission SET plan, Strategic Energy Technologies. How was photovoltaic viewed? Actually quite an interesting potential, but way out before photovoltaic, ladies and gentlemen, could make a contribution. Manfred, I think, first of all, we get CCS. Our job, ladies and gentlemen, and what we asked A.T. Koenig to do with us, is there a path there? Because we, I think, Winfred, are convinced that is the potential we can make a major contribution to this problem.
So, the question is, and there is a picture which I did 10 years ago. And so I'm quite convinced that first of all, we have already a track record to tremendously getting down the cost and price of PV. As you can see here with the green curve, whether it is Northern Europe or Southern Europe or California or all these places, and then you compare the generation cost with prices you pay as a private person or as a large industry, or you go even to the places where you have then the different intersection points. Grid parity is the magic word around that. So it was a little bit the starting of that picture 10 years ago, which we took, and to look in more detail, and that is what Anton now explains to you, in which way we structured our study.
Yeah, and I think, Wilfred, the stuff you did 10 years ago, the whole tenet of that holds true. That's, ladies and gentlemen, about getting an economic issue solved in terms of can we make this technology work cost effectively. And the other one is, can we make it work at a mass scale? Can the energy grids take it? What we did in the study is we looked basically at 3 types of scenarios. We'll discuss those a little bit. Scenario 1, we call baseline. If we don't do very much, if the world just continues as this, we could get to about 4% of electricity production in Europe by 2020. Accelerate a little bit, again don't do too much, you get to about 6%. But then you notice we're flattening out because we're reaching technical constraints. But there's a paradigm scenario where 1 or 2 other things happen, we'll talk about those, where you can get to about the 12%. And that has major, major implications for what this industry can contribute. Gunther, I think you've got some numbers to this?
And just some numbers for the 3 scenarios, and without going into much detail, that is the baseline scenario. And in 2007, 5 gigawatts in Europe. 2008 was already 10. And the baseline scenario is asking in 2020 130 gigawatts, and these are the terawatt hours produced. In the accelerated scenario, it's 195 gigawatts installed, and in the paradigm shift scenario, a massive 390 gigawatts and producing 460 terawatt hours, which, by the way, would be 1/3 of the gap which the Commission is looking for.
And only 12% of European electricity demand. We have to invest in building new capacities anyway. If you look at this worldwide, and I think Europe is taking a lead here, if we just do some top-down assumptions, what this basically means is that the type of market growth you would need to support worldwide and push for is immense. We're talking in 2020 somewhere between 80 gigawatt peaks on an annual basis and 160, depending on what the take-up of this technology is. It's huge growth, huge job creation, huge technology development, huge CO2 improvement contribution. One of the questions that I was asked, I think you were asked this as well, is that's a lot of growth, can we manage it? What about natural resource constraints?
That's the important point. And we looked with our consultancy, we have a lot of detailed information. What are the major materials we would use? And I don't go into any detail here, but the basic takeaway from that analysis is there is no technical constraint whatsoever which would hinder us to do that paradigm shift scenario. Neither in terms of materials, nor in terms of equipment, and we just have to get as quickly as possible, as you will see later, to get to the volume, as you will see.
We know there's no material constraints. We know this industry is capable of rapid growth to fulfill this need. Can we get the economics right? Can we make your chart from there 10 years ago? Well, when we actually, with the team, went through all of the cost curves, bottom up in different technologies in this sector. And these are, sorry, I must apologize for it, the market has caught up with us, somewhat old numbers. They're only 7 or 8 months old. We see about half of the costs, and we're ahead of that curve at the moment, ladies and gentlemen. On a more macro level, Wilfred, I think you've been looking at this. We know the price learning curve here. We are on track. We've had blips out because of the silicon situation, but we are moving down that curve very clearly, and I think there's a lot of empirical evidence that says this is just to be expected.